Hey guys, and welcome to a new tutorial series. So I was talking about doing this tutorial series about a week ago, and I finally got around to doing it. So this is going to be Tetris in Python with Pygame. Now this is a pretty advanced tutorial. A lot of the stuff I do in here assumes that you already have a basic knowledge of Python, you kind of know some of the syntax, and you're not a complete beginner. That being said, if you are a complete beginner, feel free to watch through, see what you might understand. You're probably going to learn something along the way. It just might be a little bit confusing because I'm kind of going to speed through a few things that I would consider like trivial right now, okay? So first step for this tutorial series is you guys have to download and install Pygame because that's the module we're going to be using. So I will put a link in the description and a card in the top right hand corner here to go and do that. I have a video, it's pretty quick, and it kind of goes through any errors you might run through when installing Pygame. So watch that first and then come back here. Okay, so let's just give a quick preview of what our game is going to look like. So this is Tetris. I didn't go too fancy with the graphics. I pretty much just want to make sure that we get everything functional here, and then you guys can play around and change stuff later on if you want to. But yeah, this is a fully functioning game. You can see it's just like standard Tetris. We have different colors, shapes are falling down the screen, shows us our next shape, and there we go, the road just cleared. So that's all I'm going to show you for right now because I want to get into actually coding, okay? So pretty much what we're going to be doing in this first tutorial is we're going to be working a bit in the main function. We're going to be creating the grid. We're going to be talking about formatting shapes, all the basic stuff, just setting up for the rest of the tutorials. So the first step, and what I need you guys to do, is you're going to download kind of like a starter file, okay? And that's just because if you see here, I scroll through my file, I got a lot of lists, I got a few things set up here, and you know what, I could go through and type them all out, but that's just a waste of a video because it takes a long time. So to save yourself time and to save me some time, what I'm going to do is just put a link in the description. It's a pastebin link. Click that link and download this code. It's just going to be all this. It just has all the functions that we're going to need for this, and then it has these shape formats, which I'm going to talk about in just a minute. So go do that. If for some reason pastebin's not working, let me know in the comments and I'll find another way to give it to you, but I'm also going to put it in the pinned comment so that you can just copy and paste it from there as well. I do recommend you check the indentation on it though, because sometimes it messes up on pastebin and in the comments. Okay. So now that you've got that downloaded, we're working on that. I'm going to be working in PyCharm. If you don't know about PyCharm, don't worry about it. You can just use IDLE, but this is just going to save me a bit of time because it auto-completes variables. It does some cool stuff, so that's what I'm going to be working in. Feel free to work in PyCharm. Feel free to work in whatever text editor you want. Just know that that's what I'm using. It doesn't make a difference, but some of the stuff I do in here, you might not be able to do in IDLE or Sublime Text or whatever you guys are going to use, okay? So we've got that all the way, we've got everything set up, and now we're ready to actually start coding and understanding what's going to be going on. So Tetris is a fairly complex game. You have shapes moving down the screen, they're rotating around, they're moving left and right. When they hit the bottom, they freeze in whatever position they're in, and then if you have a full row complete of like cubes, then that row clears and you keep going, and obviously you lose the game if you stack up too many blocks and it goes up or above the top of the screen, okay? So this first variables we need to set up is our screen width and our screen height. So we got 800, 700 here. The next ones are play width and play height. Now this is the actual red box that you guys saw. That's what these are representing. So since in Tetris we have a 10 by 20 grid, we need to make sure that our play width is exactly half of our play height so that we have perfect squares, right? So doing the math here, that makes it 30 width and 30 height per block. So that's our block size of 30, okay? So now this top left and top left X and top left Y, this represents the top left position of our actual play area. That's so when we start drawing blocks and we start checking for like collision and stuff like that, we just have these already set up and we don't have to deal with that. So the math is pretty straightforward. You guys could probably figure that out. You don't need me to explain that. Okay, shape formats. So these, and this is the longest part, this is why I got you guys to copy everything, this is what's going to represent our shapes in Tetris. Now you see that I have multiple lists inside of lists in most cases. This is because each shape has possibly more than one rotation, right? So this is the standard rotation of the S shape, and that's actually what they're called in Tetris, like S, Z, I, O, whatever. And this is the second rotation, and these are the only two rotations or whatever that S can have. So that's why we have them in here. We have a 5 by 5 grid of periods, and then whatever there's a 0, that represents where the block actually exists, okay? So Z, you can scroll through, you can kind of look at them, and you can see for some of them, for example, the square. Well, it doesn't have any rotation. If you flip it, it's going to look the same, so we only have one list here. For J, however, though, we have 4, right? Because we can rotate in different ways. L, we also have 4. T, we have 4 as well, okay? After this, I create a list, and it just holds all of my shapes. So S, Z, I, just so that way I can really easily select shapes just by indexing them in the list, like 0 through 6. And shape colors here is the same thing. It just corresponds, like for example, if I did shape 0 and I did shape color 0, then that's going to be the color of shape 0, okay? Same thing with like 6. So shape 6, well, color list or shape color 6 is the color of that shape. So it just makes it really easy. We don't have to deal with dictionaries or anything like that, okay? All right, so now we've kind of gone through the like starter file, I'd say, and you can scroll down here, you can look at the function names. I'm not going to explain them because most of them are pretty straightforward, and I'll talk about them when we start coding them anyways. But we do have a class here. Now this class is going to be the main kind of data structure, if you want to call it, for our game. And this is going to represent, or this class is going to represent different pieces. So the reason we have the class is because we're going to call this a bunch of times, and it's pretty much just going to hold the information like X, Y, width, height for our piece. So let's actually start coding this now. So I'm just going to create my initialization function or method, and this is actually the only method that I'm going to have. So I need another underscore, just butchered that. And pretty much what this is going to have is going to have an X, a Y, and then it's going to have a shape, okay? And that's the only information we need for this, and I'll show you why. So we'll say self.x equals x, self.y is equal to y, self.shape is equal to shape. And then what we're going to do here now is we want the color and we want the rotation. So self.color, well, I was already talking about this. Self.color is just equal to whatever the index of this shape is in this color list. So what we can do is we can do shape underscore colors, square brackets, and then shapes.index, and whatever shape we were given. So if we're given the shape S, well, let's just find it in the shape list, whatever index that is, well, that's the color of our shape. Pretty straightforward. And then we're going to do a rotation. So rotation, this is going to be set default to 0. And this is so that whenever we click the up arrow key, we can just add 1 to this rotation, and that will represent what shape we're actually going to be showing. Because again, remember this shape list is a multi-dimensional list. It has, you can see here, like in this case, 4 lists within it, okay? All right, create grid. I don't know if we want to do this one yet. You know what? Actually, let's go ahead and do this one. It's not too complicated. So the way that I'm going to represent the grid in Tetris, so that 10 by 20 grid, is just by creating a list full of colors. Okay, so we're going to have a 2-dimensional list, and within that second dimension, it's going to represent a bunch of colors. Okay, so I'll show you just by coding and kind of talking about it after. Say grid is equal to, and then another square bracket here for X in range 20. And don't worry, I'll explain this in 1 second. And then we'll say for X in range 10. Okay. Except here, we're just gonna do 0, 0, 0. Okay, so what I've just done here, this is like the Python way to create lists, okay, list comprehension. We're gonna create one list for every row in our grid. So since we have 20 rows, we want to create 20 sublists, and each of these like sublists or whatever 2-dimensional lists is going to have a bunch of colors in it. How many colors is it going to have? Well, it's going to have 10 colors because we have 10 squares in each row. We have 20 rows, so that's the way it works. These X's you could replace with underscores because we don't really care about the actual variable. We just need to do this that many times. Now 0, 0, 0, 0, or 0, 0, 0, yeah. I think that's right. Anyways, that's just block. It stands for block. And the way we're going to draw the grid is simply by looping through this grid, which we're going to return, and just drawing each color. So it makes it pretty straightforward, okay? Now, the only thing that we have to do here, though, is we have this locked position argument. Now, locked position, well, right now we've created a blank grid. What if there's already blocks that have been placed in our grid? So like they've already fallen, they're static now, they're not moving. Well, we need to also draw those. So to draw those, we're going to check if any of the positions in locked position are not like, or whatever positions are in locked position, we're going to get that color and we're going to change the corresponding value in the grid. I'll show that just by kind of coding it here. So for I in range, I'm going to do the length of grid, And again, this is going to give us 20 because the length of grid, well, it's 20 of these, right? Okay, so for I in range, len of grid. For j in range, and then we'll say the len of grid I, because now we're in this list, so now we're going to do whatever the length of that list is, okay? I'm going to say if this, so if j, comma I, because j is our x value, I is our y value, because rows are represented by I, and the columns are represented by j, in locked position. And just so you know, locked pause, it stands for locked position. It's also a dictionary, so you can see that it's a blank dictionary here, and each position, so like for example, if I had like 1 1, is going to be set equal to a color, and the color could be something like 25500, okay? And we're going to talk about that and create that later, but that's just something you need to know for now, okay? So if ji in locked position, so if that key exists, let's figure out what that key is. So that key is going to be equal to, well, locked position, or what the value is, sorry, associated with that key, ji. Now we're going to change whatever the current grid position is here. So for grid ij is equal to c, okay? I know this might seem kind of complicated, but pretty much we're just looking through this grid, and we're going to find the corresponding position to the locked position and just change that color in the grid so that later when we draw it, we get an accurate grid, okay? And you guys will see how this all is kind of plays out later if it seems a bit confusing now, okay? And then we're just going to return that grid to wherever we're calling it from, okay? So that's one part done. Now we can move down and we can go into draw window, which is actually, let's do get shape. This one's really easy, okay? So this is literally a one-liner, return random dot, actually, what is it called here? I gotta have a look. I think it's random dot choose, random dot choice. That's what it is, random dot choice. And then we're gonna be given a shape list. So we'll say shape. Actually, let's just, what do I call it up here? Sorry guys, shape. Random dot choice shapes. All this is gonna do is it's gonna pick one of these shapes, and it's just going to give it to us so that when we need to create like a new shape falling down the screen or whatever, that's all we have to do, okay? So get shape, random.choice. That one's really easy, okay? Next one, draw grid. All right, so what we're going to do is we're going to be passed a surface, and the surface is obviously what we're going to be drawing on. So we're going to start by just changing the surface, surface.win, surface.fill, with color. In this case, the color is going to be black, okay? Surface.fill is 0, 0, 0. All right, next thing we're going to do is we're just going to draw like a title on the thing. So the way we have to do this is we first have to start by initializing the font object. So I think we do pygame.font.init, okay? This just means we're setting up font and we're getting ready to draw to the screen. We're going to create a font. It's going to say font is equal to pygame.font.sys, capital SYS font. And then we need the font name. I'm a Comic Sans guy, so I'm going to use that, Comic Sans. Size of the font, I believe. Yeah, size of the font, we're going to do 60, okay? So the way you want to set up your own font, you want to change this, just change this to any font. You can look up fonts on the Pygame website, and then just give it a size. If you know the name of a font, type it in here. It probably exists in Pygame, all right? So now we're going to need to set up a label. So I'm going to say label is equal to font.render. And then in here, we need the text that we're going to render. In this case, I'm going to call Tetris. We need our anti-aliasing of 1. And then I believe we need a color. In this case, I'm going to make it white. Okay. So text, anti-aliasing, just set this 1. I don't know why you need to set this 1, but just set it 1. And then whatever color you want your label to be. Okay, now that we've got the label, we need to draw this label on the screen. So let's blit it. Not win. I'm used to typing win. Surface.blit. And then in this case, we're going to blit the label. Where do we want to blit it? Well, now we want to figure out where the middle of the screen is. So we could just hard code this in, but if we ever want to change the dimensions of our screen, we want this to just automatically kind of adapt to that. So we're going to do top left X plus play width over 2. Okay, and that's going to give us the middle of the screen. If you don't understand that, let me know and I can explain it to you in the comments down below. Okay, now we're going to subtract this. Sorry, this isn't actually done yet. By the width of the label, because this is going to matter. Depending on how long the label is, it's going to determine where we place it on the screen. So we're going to get the width of the label and we're going to divide that by 2. Okay, so now we need to do the Y. Well, the Y is pretty easy. We can just statically type this in because it's from the top of the screen. So I'm just going to give it, I think like 50 is what I typed in, 30. Okay. and that should put it in the middle of the screen. And I can explain that to any of you guys that might not understand it. If you just leave a comment, because I don't want to waste too much time, because I think a lot of people might understand that. So for I in range now, the len of grid, because now we're going to start drawing all the grid objects onto the screen. So we created a grid. We know how that kind of format works. We're going to say for j in range, the len of grid I, same as before. And then we're going to do Pygame dot draw dot rectangle, and then in this case we're going to draw on the surface, and then we're going to go grid I j, okay, and then top underscore left. I need to put this in, what do you call it, brackets here, top underscore left, so I just need to scroll over, top left underscore x plus j multiplied by 30, and I'll talk about this one in just a second how this works. And then top left y plus I multiplied by 30. Another bracket, and there we go. Now we just got to deal with this grid thing, so that means that we just now need to pass grid as well into our draw grid. Okay. The way this works, we're going to loop through every color within our grid. So this is the color, grid IJ, all right? This is the surface we're drawing it onto, and this is the position in which it's being drawn. Now we also just need to add two things here that I realized I forgot, because we need the x, y, we need a width, and we need height. So for width and height, well, that's equal to the block size, and block size once again. And you know what, we can even multiply this instead of by 30 by block size in case we ever decide to change that. So let's do that just to keep this nice and dynamic. And then if we keep going over here, the last thing we need is a fill. So we're just going to put comma 0 to make sure that we fill in the shape. We don't just draw like a border for it, okay? The way this works, we get our top left x, and we're going to figure out wherever we are, so which column we're in, multiply that by block size, and that's our x position. Same thing works for the y. With the starting y position plus whatever row we're in, multiplied by the block size, will give us the correct position to draw our cube in, okay? After we've done all that, we just need to update the screen, so pygame.display.update. And there we go. So there's actually one last thing we want to draw, and it's that red rectangle that you guys saw, and that kind of represented like the play area. So to draw that, we do pygame.draw.rect, and then surface, and then in this case, we're just going to actually, let's see here, do I want to dynamically type this in, or do I want to just statically draw it? So let's give it a color, first of all, of red, 0, 0, 0. Okay, and we're actually going to type it in dynamic, just in case we decide to change anything later. So top left x and top left y, and then the width. Oh, we actually already have all these variables, so we have the play underscore width and the play underscore height. And in this case, we're going to give it a border size of 4. Okay, and that's all for drawing the grid. We might come back to this later, but for now, that's it. Okay, so this just draws the actual grid. Draw grid, and I've added this. So, okay, we're just going to copy this part here, guys, that says draw grid, so surface.blit, this label, and I'm just going to move this in because I realize I have another function called draw window. So in draw window, what I'm going to do is surface.fill, whatever. Okay, so we're going to take surface and a grid, so I've just copied some of it from there, and then instead of updating the screen here, we're going to update the screen over here, and we're just going to call our draw grid what do you call it, function like this. Okay, so now if we want to draw the grid and we want to use this in another program, we could just copy and paste this function. We wouldn't have to kind of take it out of here. We wouldn't have to like dissect it. All right, okay, so draw grid, again, this takes surface and this takes grid, and there we go. I believe that's working well. Okay, now that we've done that, we're going to start coding in the main and in main menu, and this is what we're going to finish off with in this tutorial, because I know we're almost at the 20-minute mark, right? So what we're going to do in main now is we're going to set up a few variables. So the first variable we need is this locked positions, okay? And again, this is what we're passing up here into create grid. It's equal to a blank dictionary to set. In case we don't pass it, then we don't need it, okay? So locked positions equals blank. We're going to say grid is now equal to, well, create grid, because we already created that function with locked positions passed to it. We're going to create a variable called change underscore piece. It's going to be equal to false. We're going to make run equal to true. This is just for our while loop that we're going to use. We're going to say current piece is equal to get underscore shape. Okay, we're gonna say next piece is equal to get shape as well. We're gonna set up a clock object, and clock is equal to pygame.time.clock. And we're gonna set a variable called fall time equal to 0. And those are all the variables that we need in our main function, already coded for us, okay? So now we're gonna set up our while loop. This is our main game loop. We're gonna say while run. First thing we need to do in our loop is write for event in pygame.event.get. Then we say if event.type equals pygame.quit. Well, that means we need to quit the program. So the way that we can do that is just simply hitting run equals false. It's going to break us out of our while loop, and then we can deal with that afterwards. We're also going to add another event. This is a key down event. So if event.type equals pygame.keydown, like that, then we're going to check what specific key is actually hit. So let's go ahead and do this now. Can I get it over with? So I'm just going to type all the different keys, and then we'll go in and code that after. So we'll say if, what do you call it? Pygame.key equals, I believe that's what it is, or event.key, not pygame.key, my bad guys. Event.key equals pygame.k underscore capital K, K underscore left. We say if event.key equals pygame.k underscore right, like that. And then same thing with up and down. So if event.key equals pygame.k underscore down. And last one, k underscore up, okay? Okay, I don't know why that keeps happening. Okay, k underscore up, like that. Okay, so painfully after typing that, left, right, down, up, now we can go in here and we can kind of code what each of these is going to do. So if we're hitting left, we want to move our block left. If we're coding right, if we're hitting right, we want to move our block right. And we're going down, we want to move down. We're going up, we want to rotate our shape. That's what the main things are going to do in here. So if we want to move our piece left, well, we should change the x value leftwise, okay? So the way that we can do that is going to say current piece dot x minus equals 1. Now, I know you guys are looking at this right now and you're saying, okay, well, what the heck, man? So current piece is equal to get shape. And that's all it's equal to, get shape. Well, what is get shape? And it's just returning random.choice shapes. Now, this actually just made me realize the fact that our get shape thing needs to change a bit. That's because we need to actually create a piece in here. So we set up this lovely class up here and we weren't even using it. So piece, random.choice shapes is the last argument it takes. It also takes an x and a y value, right? So for the x and the y, well, the y is pretty straightforward. It's just going to be 0. The x has to be the middle of the screen. So we're going to give it 5. And for y, we're going to give it 0. Okay? And actually for y, we'll leave it 0 for now, but we might want to make it negative so that it kind of starts above the screen and then starts falling down. Okay? So we have, let's make sure this looks right, XY shape. Yeah. Okay, great. Okay, so that makes sense now, how we could change this x value. Same thing for right. I'm going to do current piece dot y, or dot x plus equals 1, like that. And for down, we're actually just going to type this in for now, but this is not exactly what's going to work. Y plus equals 1 to move downwards. And for up, well, we need to rotate the shape. So to rotate the shape, this is actually pretty easy. All we're going to do is current piece dot rotation plus equals 1, okay? Because when we change that rotation, well, that changes the actual image of the shape, okay? Now, this is all great, but the thing is, what if we're moving off the screen? Or what if this is not a valid position? Well, that's why we have a function called valid space. Now, valid space, we haven't yet coded, but I do have it in here somewhere, valid space. And what valid space is going to do is it's simply going to return if the current position that we're in is a valid space. So the way that I do this, and this is going to just make life a lot easier. If we're moving left, let's simply just change the piece as x, move it left 1, and then check if that's a valid position. And if it's not, well, then we can just add 1 and move it back to where it was. So we're going to say if not, and then valid space, and valid space is going to take 2 arguments. It's going to take the current piece, and it's going to take the grid, okay? Then let's just simply subtract or add 1 to our piece. So all this is saying is we're going to move left, but if for some reason moving left results in not a valid space, well, let's just add 1 and pretend like we didn't even move there. So we're not drawing it, we're not changing anything, so this is perfectly fine, and it's actually a really easy way to check things without having to checking if it's below this or above this or whatever. Okay, so now next one here, we're going to say if not valid space, and same thing, current piece with grid. Well, now in here, instead of adding 1, we're just going to subtract 1 because we were trying to move right, and there we go. Same thing with moving down. Okay, so we're literally just going to type the exact same thing, if not valid space, current piece, and grid. Well, now instead of adding 1, we're just going to subtract 1, and this is from the y value this time, so we say current piece dot y minus equals 1. Okay, so now for up. So when we change the rotation, we are changing the shape. Okay, so it doesn't show this yet right now, like how we change the shape, but we're going to do that later. So we can actually just call the exact same thing on rotation, because think about it, if we're fully on the right side with like the straight piece and we try to rotate, well, that could result in our piece being moved to the left or to the right, or like there could be positions where it's on the left or it's on the right and it's not in the grid. So we do have to check for rotation if it is a valid space or not. So we'll say current piece, and then what else are we doing? Grid here. Okay, and then in this case, again, we'll just subtract 1 from rotation, so minus equals 1, and that should all work pretty well. Okay, so after we do that, we're going to make sure that we remember to draw the grid. So in this while loop, we'll say actually draw window. I'm going to give it surface, and we're going to give it grid. Now this reminds me that I haven't yet created a Pygame surface. That's great, so let's do that. So here I'm just going to say when equals pygame.display.set_mode. In this case, I'm going to give it, what is it, screen width and screen height. So s width and s_height. And that's it for our display. We want to give this a caption though. So we'll say pygame.display.set_caption. Yep. So let's just call this Tetris like that. And now we're going to just pass win into our main menu. We'll put win here, and then in main menu, we're going to call main. Okay, and we'll deal with main menu later. I don't feel like coding it right now, and it's not really important to like the main functionality of a game, so we can simply just do this. Okay, main win like this, and if I put win here, then everything should work out. This says surface. Change this to say win in lower cases. Okay, so now we've effectively done draw grid, or draw window, draw grid, get shape, create grid. We've created a piece. We've gone through what all this stuff in the starter file does, and we are now at 27 minutes. Okay, so I think this is a good time to take a break, kind of digest everything that we've just done here. I know a lot of it doesn't make sense yet because we haven't actually coded a lot of the functions, but trust me, as we go through the videos, things are going to start to make sense. You're going to see how all this stuff works. Again, as I mentioned, it's pretty complex, so until I kind of go through everything at once and explain it all at the end, like how all this stuff kind of fits together and works, it might seem a little bit confusing. Anyways, that's it for the first video. If you guys are excited about this game, you want to see the rest of it, please make sure you leave a like and subscribe, and I'll see you again in the next one.